All right, let's talk about something we all use every single second we're online, but probably never even think about. We're going to break down the absolute fundamental building block of the internet, the unsung hero that makes it all work, the IP packet.
I mean, really, have you ever stopped to think about it? You type something into a search bar, you hit enter, and poof, the website just appears. How does that happen? Well, I can tell you it isn't magic. It's an incredibly detailed and structured system, and right at the very heart of it is the journey of one tiny, tiny packet of data. Okay, so here's our game plan for today. First, we're going to look at the digital postcard idea. Then, we'll get into why the address your computer uses at home isn't good enough for the wider world. After that, we'll really get our hands dirty and dissect a packet, trace its journey step by step, and then finally, we'll zoom out and see how this one brilliant concept connects literally everything.
So, first things first, let's start with a really simple idea. If you want to send a letter across the world, you can't just write a message and, hope for the best. You have to put it in an envelope, you have to address it, and you have to send it on its way. Well, the internet works in pretty much the exact same way.
And this is the solution. Any data you send online, doesn't matter if it's an email, a cat video, or just a simple click, it all gets chopped up into little pieces and stuffed into these digital envelopes. Each one of these packets is a totally self-contained messenger, ready to find its own way across the massive, tangled web of the internet.
Okay, but here's where it gets really interesting. To make this whole global system work, just one address isn't enough. Every single device on a network, including your phone right now, is actually using two totally different kinds of addresses, one for talking to its neighbors and one for talking to the rest of the world.
Let's think about it like this. A MAC address is like a nickname. In your house, on your Wi-Fi, everyone knows who my laptop is. It's perfect for devices talking to each other right there in the same room. But what happens when you want to send a message outside that room to, say, a server in another country? That nickname is totally useless out there. For that, you need a globally unique IP address. That's the internet's version of a full official postal address.
All right, time to pop the hood. We're going to open up that digital envelope and take a close look at the really precise structure design that allows this little packet to navigate across millions and millions of different devices without getting lost. And you know what? For something so powerful, it's actually beautifully simple. Every single packet is broken down into two main sections. You've got the payload. That's the actual stuff you're sending, the content of your letter. And then you have the IP header. That's all the important addressing and handling info. That's the envelope itself. Now that header, that is where all the magic happens. It's got the source IP, who sent this, and the destination IP, where is this going, but it also has other critical info, like the protocol, which tells the computer on the other end what kind of data is inside. And it has a checksum, which is a clever way to make sure the address information hasn't been scrambled along the way. And one of my absolute favorite fields in the header is this one, the time to live, or TTL. This is such a smart little failsafe. It's basically a countdown timer. Every time the packet jumps from one router to another, the number goes down by 1. If that counter ever hits 0, the packet is just destroyed. This brilliant little feature prevents a lost packet from just bouncing around the internet forever and gumming up the works.
So let's make this real for a second. When you connect to Google, every packet leaving your laptop has a source IP address that's private to your home network, something like the one you see here. But the destination is a public global IP address for one of Google's giant servers, and it's your home router that does the amazing job of translating between the two.
So how does this packet even get made in the first place? It doesn't just appear, right? Your simple request actually goes through several distinct layers of preparation before it's even ready to hit the road. It's a fascinating process. Think of it like a set of Russian nesting dolls. It all starts with your actual request. That's the application layer. The transport layer then wraps that up to make sure it gets there reliably. Then the network layer takes that and puts it inside our IP packet, adding those global addresses. But wait, we're not done. For just the very next jump from your computer to your router, the data link layer wrapped the entire IP packet in yet another layer with those local MAC addresses. And finally, the physical layer turns that whole bundle into electrical signals or pulses of light and sends it flying. So let's trace the path this thing takes. It leaves your laptop and goes to your router. Your router rips open that outermost layer to read the global destination IP, then wraps it in a new local layer for its next hop to your internet service provider. And this exact process, this unwrap, read, and rewrap cycle happens over and over again at every single stop across the internet until, bam, it finally arrives at the Google server. Okay, So as we start to wrap up here, it's really important to zoom out and realize what this all means. This whole system, this detailed structure of an IP packet, it isn't just a clever bit of engineering. It's a global standard. It's a universal language that every single network device on the planet has agreed to speak. And really, this is the big idea. This simple, highly structured digital envelope is the very thing that allows thousands of completely separate, independent, and sometimes competing networks all over the globe to connect and act like one single massive entity, the Internet. It's the quiet foundation of our entire modern world.
I mean, just think about that. This design, created decades ago, has scaled so incredibly well that it holds our entire connected society together. But as the internet keeps growing at an insane pace, it does leave us with a pretty fascinating question to ponder. How does a system this fundamental, this deeply embedded in everything, change and evolve for the future? And what will the packets of tomorrow even look like?